Hi, this is Steve Hosher, and I'm going to do a short tutorial on how to use the RazorGage software. When you start the RazorGage up, you'll get a screen that says press OK to home. You press OK, and after the RazorGage positioner homes properly, you'll get the main screen, which we're seeing right here. Starting from the upper left, we have the current position, which in this example is showing 0. After you set the offset or the calibrate the machine, this will say something else after homing is complete. Below is the target position. That's where you'll, if you start punching in numbers, those will appear in the target position box, and when you press enter, the RazorGage will go to that position. The off target light turns green when the RazorGage is in position. Since I'm using our demo software, that is going to stay red because we aren't getting anything back from the RazorGage saying it's in position, since this software isn't hooked to a RazorGage. This absolute mode determines what happens when you put numbers into the software. In absolute mode, if you put in 12 and press enter, the RazorGage will go to a position of 12 inches away from home. If the home offset is set to 0, as it is in this example, it would move to 12 inches from wherever it is. The incremental mode is a little different. It's for pushing material. As you can see, when we click incremental mode, we get these labels here. One says increment 0, the other one tells us what the saw curve is currently set to. So in this situation, if I put 12 and press enter, that's the increment, so it's going to advance from the current position that it's in 12 inches plus the saw curve. In this way, if we are pushing material, we'll get a 12-inch part on the other side of the saw blade, which is, by other side I mean the side opposite of the RazorGage, as the RazorGage is pushing a long stick through, and the part that's getting cut is going to be on the opposite side because we are pushing. Now if I press go, it would, if this was hooked to a RazorGage, I'd get an error because I'm at 0 and I'm trying to advance 12 inches. If I click the load button and there was a RazorGage hooked up to this, it would go out to whatever the current load position is defined as, and then I could start pressing go, and every time I press go, the RazorGage positioner would advance 12 1/8 inches in this case, because my increment is set to 12 and the saw curve is set to 1/8. So that is how incremental mode works. I'm going to click absolute mode to take it back to absolute mode. Here, of course, is the number keypad. This is where you put in lengths, dimensions for the RazorGage to move to. If I use the plus and minus button, I can just say +1, for example, and the RazorGage will advance 1 inch. Or I can use -1, and the RazorGage will advance 1 inch. I can also use these fraction keys. I can say -32, and the RazorGage will respond accordingly. The fraction keys are used to help you enter numbers that have fractional components quicker. You can say 12 1/8, and it'll just, the RazorGage will move to that position as soon as you hit the 8th button. You do not have to press enter after pressing a fraction key. So if any time you want to just move to the position of 1/8, you click 1/8 and the RazorGage will move from wherever it is to a position of 1/8 away from low limit or home. This offset button, if I click that, I have 4 offsets. These are values that get subtracted or added to whatever position you enter in absolute mode, and the name is a name that you can apply to an offset so that you know what it means. So if I enter test for offset 1, I see the label and which offset is enabled. I don't know why you would ever want to subtract 144 inches, but you could. So that means if I entered a length of 150, it would subtract 144 from it and move to a position of 6. And so on. This one adds, offset 2 adds a quarter of an inch to whatever number you enter. Offset 3 adds 3/8 to whatever number you enter, and so on. And then select none means it sets it back to no offset. It's important to know that all these numbers add to the main offset. And I'm gonna, when I talk about the offset, as I have a few times so far, I'm talking about a parameter that tells the razor gauge how far the end of the stop is from the saw, if a saw is what we're using, when the razor gauge is at home. It gives the razor gauge a point of reference to the material world. And I'll show you how to set that right now. As soon as you get your razor gauge all set up and attached to your saw, and you've adjusted the stop extension so that when the razor gauge is at home, the stop extension is as close to the saw as you want it to be, then you need to tell the razor gauge basically how far is my stop from the saw. Or if you're using a drill, it would be how far is the stop from the center line of the drill. If you're shearing, it would be how far is the end of the stop from the shear line. And basically it's just telling us when the razor gauge is at home, how far is it from the process. To adjust that value, you click the Setup Screen button and you enter the password, which is 90210, and then you press the Calibrate button. And once you get here, you follow these instructions. Now there are 2 steps. Step 1 is for setting the home offset, which we've been discussing. Step 2 is for the scale factor. You normally do not have to do step 2, so if it's the first time you're calibrating, skip step 2. And the software, if you follow these instructions, will give you the option to skip step 2. So that's how you set the offset. When you're done with this process, the razor gauge will know how far the stop is, or pusher, whichever term you wish to use, how far it is from the processing center, processing line. In the case of a drill, it would be the center of the drill. In the case of the saw, it would be the face of the saw closest to the stop. When you get done with this process, that will all be set up. I'm going to click Cancel and Return to Main, which takes me back to the setup screen. All these parameters are things that may need to be set from time to time. These system parameters in the upper left corner here, you shouldn't have to set. They are the stroke and the scale factor. The scale factor is a number that represents the number of encoder counts per inch of travel. If your parts are, if short parts are off, are perfect, and long parts are off, and anything in between is progressively worse towards the worst case and the longest part, then it's a scale factor problem. That is addressed in step 2 of the calibration routine, but you normally won't have to change it. Saw parameters, these are if you have a saw hooked up to the machine. You can, in other words, if you have what we call our BMI Plus or the auto cycle option, these timers adjust the time elapsed between clamping and sawing and how long the saw output is on. This little instruction or description right here where my mouse is, this shows the process that the razor gauge goes through when activating a machine. Step 1 is to turn the clamp valve on. Step 2 is to time out for the timer 1 duration. In other words, it's going to wait after you turn on the clamp the timer 1 amount before it moves to step 3. timer 1 is this value you put in right here in milliseconds. So we're going to turn on the clamp, we're going to wait for timer 1, then we're going to turn on the saw valve. And so that means the saw cylinder is going to extend or retract, as the case may be, depending on the design of the saw. So it is going to extend for a time, and then we're going to wait for timer 2, which is this one, and then that valve is going to turn off, which typically will make that saw then retract back to the home position. Timer 3 then is the delay between after the saw valve is turned off and till the time that we release the clamps. Usually you can get by with a very minimal amount of time there. So that is how the timers work. These are the user parameters right here, kind of in the middle. We have speed, acceleration, and deceleration. Now those are mean just exactly what they say. It's the accelerate, the decelerate of the razor gauge motion, and the speed of the razor gauge motion. Run current, we usually set it at 100%. You can reduce it. That means the razor gauge is going to push with less force if you reduce it. Load speed refers to when I was talking about incremental mode and you push the load button and it goes out to that position for loading. This is how fast it moves in that case. Sometimes you may want the speed of the razor gauge during normal operation to be greater or less than the speed with which you load. The unload has to do with when you're in absolute mode. There's a button on the screen that says unload, and this will allow you to back up, or when you press that button, the razor gauge backs up so you can maybe get a short part out from near the saw and then move back to cut another part. This is the distance that it backs up when you press the unload button. Load value, load parameter, that is how far out it goes when you're in incremental mode to allow you to load a new part for pushing. The saw curve, again, only applies to pushing applications, and that is the curve that the saw leaves when it cuts. The offset is that offset value that we've been talking about. You can adjust it manually here, but it's much easier to just click the calibrate button and it sets it for you. This box here is for defecting I/O. We don't do that too much anymore, so you generally aren't going to have to worry about that. The button in the lower left corner, this area here, is for setting whether the razor gauge is on the left or the right side of the saw. For changing hand on the RazorGage ST, you just take the carriage overbar off, flip the razor gauge over, now you can put the carriage bar back on, and you can change it from left to right. These buttons, left and right, don't affect how the razor gauge homes, but it does affect how some of the screens are displayed so that they look right with your physical arrangement. If you uncheck ST, extrusion, then it will actually home on the side opposite the motor. So that's how that works. Now these buttons in the middle here you won't use too much. Move to lower limit moves the razor gauge to the lower limit. Move to upper limit moves it to the high limit. Controls test is interesting. If you have a BMI, basic machine interface, you will have possibly a tool safe sensor and an air safety. If you have an auto cycle option, you will have some I/O. If you have defecting, which again we don't do a lot anymore, we did at one time on the auto list, it will give you indications there as well. Mainly what you're going to be interested in is this button here that says saw safe input. If you go to this screen and you push the button on the saw safe limit switch that ships with the machine when you order the saw safe sensor or tool safe sensor, this little circle here will turn green to indicate that that is working. So it's good to know about this. If you have our two-hand USB input, which is for testing and setup of a machine that has a saw on it. We have a USB two-hand anti-tie down, or it's not an anti-tie down, it looks like one. It's a two-hand trip that enables you to it's not for production use, but it is used for setup. For example, cutting a sample part to adjust the offset. This will tell you that that two-hand button is coming on. And that's the controls test. You won't use, well, you'll use home the positioner. That just homes the RazorGage from within the software instead of having to restart it. You won't use these two machines, run laser routine or run break-in. That is the entirety of the setup screen. The AutoCalc screen, this is a screen that has some interesting functionality. You'll notice at the top we have these two text boxes that enable you to enter values. One is basically an X and one is a Y. These two variables can mean anything. But if, for example, you were making a window and you used rough opening size as the basic size for a window, you could put the width in here and the height in here, but maybe you're going to cut sash parts and nailers and trim pieces for a window based on the rough opening size. Each of these boxes here can be defined to calculate numbers based on that X and Y. So you can put all kinds of equations in these, behind these boxes, and a label, and you can even put a picture in that box. And you do that by clicking browse to image, browse for image, and you can put a picture in that box, and that way when you click at this button, it will perform that math on these numbers that were entered here and move to a position based on that. So you could have several parts that get made for a window where you just enter the rough opening size and then click each of these buttons, and you can have a picture of the part that's going to be cut when you click that button, and the RazorGage will move to a position that is calculated based on the X and Y, or the X or Y or both, that you enter here. So you could enter rough opening and click on each one of these and cut the proper length parts for the different parts of the window. And this page plus just creates a new page, and you can have as many as you want. It's just if you have very many, then navigating can become a bit of an issue. Here you can see it went to page 2. I'll hit page minus, it goes back to page 1. And again, you have the unload button for backing up to get parts out. This screen is using the RazorGage as a stop. Auto pusher screen. This is a screen that you can enter a push pattern and save it and recall it later. To define a push pattern, you click in right here, board settings. So overall length, maybe you've got a 192-inch or a 16-foot material that you're going to be pushing. The load position you might put at 195 because you want the load position to be further out than the overall length. Head trim, that's the leading edge trim. You might want a 1/4 of an inch there. And then I'm going to click in the quantity, and maybe you want 5 parts that are 24 inches long. Well, we'll say 24.375. And then click the enter button, and those parts get put on this push pattern. And if we look right here in status, we see the remaining is 69.25. So let's say we've got one piece that's 68 inches long. We can stick that in there, and now we're down. We only have an 1 1/8 inch left. Shows you what the kerf is. That's reflecting the kerf setting for the machine. It's not, you can't save the kerf for every different board. And that's essentially how that works. You can increase the stack quantity. That means, say you're going to set up this board and you're actually going to stack 3 boards on the table and push all 3 at once. If you click 3 here, then as we cut parts, this counter will increment by 3 instead of by 1. And this counter tells you how many parts you've cut. So that's how that works. Then to save that board, you click Save Current Board, and then you type in a name. and then it will come up with the Windows Save As dialog box, and you can control where on the computer you want to save it, and give it a different name if you want to. Then later you can open an existing board and go to wherever you need to be on the computer and find that board and open it. That's the auto pusher screen.